Let's talk about risk assessment. Several problems crop up software projects. Some of them are so common that in the industry has termed the anti-patterns. Anti-patterns negatively impact project success. However, it's more than just anti-patterns. In this lesson, I'm going to talk about how to assess the likelihood and impact of risk in your project. Anti-patterns represent common risk, but from this point onward, let's think of the risk as anything that could potentially cause your project to fail. Those could be anti-patterns, but we will also include the project-specific risks that might not be common across projects. Risks represent potential ways in which your product could fail. We want to be able to do something about minimizing risks. Knowing potential project risk is the first step. Planning for them is your next step. So you already have a list of potential risks. How would you determine what to do about them? One way is to be a proactive leader and take actions to avoid the situation entirely. And of course, you cannot do this for every risk on the project. You would spend more time tackling proactive actions than making real progress on the product. And this is why we need some way of prioritizing risks. And that is where the impact versus likelihood matrix comes into play. An impact versus a likelihood matrix is 2D representation of the amount of influence a risk has on a project. It shows what you need to focus your efforts on preventing. An impact versus likelihood matrix looks like this. You have impact running along y-axis from low to high and likelihood running along the x-axis from low to high. So to use the impact versus likelihood matrix, simply assign any risk associated with your project a value along each axis. For example, see you had the risk of project runs out of funding. This risk would have a huge impact on your project because it would be forced to shut down. Assign this risk high on your impact domain. And say you are working on a startup with limited funds. This could be the project risk of running out of money and put it a medium. So with these two values, you can place project runs out of funding in the upper middle cell of your project, like this. So as you can see, it is important to understand what are the project risks so you can know how to handle them. Now let me give you a couple more examples of project risks. Let's say asteroid destroys the Earth. Developers quits. Technology fails. Or client lose interest, and so on. So all of these are potential project risks, and they all present ways in which your product could fail, although some are more dramatic than others. Like this first example, for instance, this could be a high impact event, but given that we aren't likely to see any asteroids destroying the Earth anytime soon, the likelihood is low, so asteroid destroying the Earth gets put in the top right corner of your matrix, like this. Now let's talk about another one. You're working on a team with a developer named John. John is notorious for having his development computer die on him halfway through the project. And this is a project risk. So what do you think? Where would John's computer die sit on your matrix? If there are other machines on which John could develop, it might impact John, but the project will probably be okay. So let's assign his impact as low. However, since his computer dying has been established as nearly inescapable, the likelihood is high, and therefore John's computer dying is placed on the bottom left-hand corner of your matrix, like this. Now let's look at the matrix again. Do you see those numbers in each of matrix cells? Those represent a risk category as determined by each risk value on the matrix. The project running out of funding would receive a value of 2 because it is high impact with a medium likelihood. Strays destroying the Earth would receive a 3 because it is high impact with low likelihood. And John's computer dying would have a 3 because it's low impact and highly likely. Now that you have a list of risks and they are all associated risk categories, so what do you think what to do with this? This value represents the potential magnitude of risk on your project. It tells you what level of action you should take regarding the risk. A or high impact, high likelihood risk should be addressed as thoroughly as possible. Since the impact would be high and it also likely to happen, the best course of action is to take steps towards mitigating that risk as much as possible. Any action you take right now, you should do it if that action mitigates the influence of the risk category 1. A 2 or medium risk would be something you should be concerned about, but don't need to do anything about it right now. There should be a thorough risk plan and strategy for how to deal with that when that risk occurs. And a 3 or low risk is something that isn't very much concerned to your project, but you should still keep an eye on it. You should monitor these risks, but don't spend too much time thinking about what would happen if they occur. And there are other variations of this ranking system. The example we just used assigned the only risks that are high impact and high likelihood. More conservative projects may assign 1 to risks that are high impact, high likelihood, high impact, medium likelihood, or medium impact and high likelihood. And then 2 will be distributed along the edges of those cells, and 3 to everything else. All this does is assign higher importance to some risks. Effectively, this means that you are decreasing your project risk tolerance, something that you may be interested in doing if you are involved in a mission-critical project. And just be aware that taking actions for a risk will add activities to your project plan. In turn, this will influence your project deadlines and costs. Now, one more thing is very important. This concept of placing risk on metrics can also be applied to your project features. So to do this, use a risk value matrix for your features. A risk value matrix is a lot like an impact versus likelihood matrix. So just instead of having an impact on the y-axis, you would have a risk. And instead of likelihood of x-axis, you would have a value of the feature to the project. So like you did with the project risk, you can put features into this matrix, which can help you decide how to prioritize these features. Say you're building a product that uses a user-facing app and database to store data. Your developers have a lot of experience with creating apps like this, but have very little experience with creating databases. So in general, features that involve the app will be placed in relatively low risk and high value, and features that involve the database would be high value and also high risk. So how do you assign priority based on this? Well, when I first saw this matrix, I automatically assumed that you should start by creating features with high value and low risk. I thought this because they would deliver value quickly to the project. However, I soon learned that it is far better to build your high-risk, high-value features first. This is because by taking the larger risk first, you will effectively tackle the problems with the product that poses the most danger to the project's success. If you run into issues that force the project to be delayed or cancelled, it's better to find them early rather than later on the project. And you can use the same principle for writing risk to rank features and prioritize their development. So let's recap this since it's very, very important. When prioritizing features using a risk-value matrix, you should focus on getting high-value, high-risk features first. So the idea here is to fail fast if something were to go wrong. It's best to find out early as possible. And that is a risk assessment. See you in the next lesson where I'm going to talk about how to create a risk plan.